Hello everyone, my name is Arya Kumar, lecturer in Computer Engineering Department. Today I am going to take 8th practical of DSU subject, that is insertion and deletion operation in queue. So practical number 8 is perform insertion and delete operations in linear queue using array. Practical outcome of this program is write C program to perform insert and delete operations on linear queue using array. Let's see the algorithm for NQ. NQ in queue means to insert a particular element into an array. Let's take A max, that is array n, total size of an array. Then if rear is equal to max minus 1. Now if you want to insert a particular element in this queue, in that at that time rear should be equal to, if rear is equal to max minus 1, then queue is full, which means insertion operation is not possible. At that time queue is full, like this message should be displayed. If rear is not equal to max minus 1, in that case, if front is equal to minus 1, then it means that queue is empty. So we need to set front is equal to 0. Then set rear is equal to r plus 1, that is rear plus 1, which means whenever we are inserting a particular element, front and rear will be incremented by 1. When first element is inserted in a queue, at that time front should be set as 0. Then at the rear element, the particular new element will be inserted. Algorithm for DQ is, in this case, if front is equal to minus 1, which means no element is present in a queue, queue will be displayed as empty. Because if queue is empty, we cannot dequeue element from that particular queue. If then else value should be set as equal to queue front, and front will be incremented by 1, because whenever we are deleting a particular element from a queue, front should be incremented by 1. And in this case, if front is greater than rear, then set both rear and front is equal to minus 1. Let's see the program of the same. Let's see the program of queue. As include stdio.set encoding header file. As defined, max as 50. This means we are declaring max value as 50. This is for array elements. R stands for rear, which will be equal to minus 1 as no element in an queue. Front, for front I am taking f variable, f is equal to minus 1 again. Void main function in this. So taking choice from user, choice variable is there, while 1, in this case while loop should get executed. Let's give choices, operations which we need to perform. First is insert, second delete, third display, and fourth as exit, or you can say switch. Now take choice from user, which will be stored in variable choice. Then start with switch case. In bracket, choice. Let's take case 1. enters first choice, then insert function should get executed. If user enters choice as 2, then delete function should get executed. If user enters choice as 3, then display function should get executed. If user enters case as 4, then it should get exit. Let's close switch case here, then closing of while loop, closing of main function. Then start with insert function. Elements which we are going to add will be stored in add variable. Now we can add elements or we can insert elements to a queue only if there are spaces available in queue. So let's check out whether where is equal to max minus 1. If this is the case, then we cannot insert elements in a queue. So message should be displayed as queue is full. If this is not the case, then else part should get executed. In this, again, I am checking if front is equal to minus 1 or not. If front is equal to minus 1, which means queue is empty and we need to set front is equal to 0. Printf. Insert element scanf, which will be stored in variable add. When element is inserted in a queue, at that time where will be equal to where plus 1. Because whenever we are inserting a new element in a queue, where will be incremented by 1. In that location, queue R, that means where location will be stored with add element. Here I am closing else and then insert is getting closed. Then second function is delete. If now deletion is possible if elements are present in an array, that means in a queue. If queue is empty, then deletion is not possible. So let's check whether element is present in a queue or not. For that, if front is equal to minus 1 or front is greater than R, if this is the case, then printf queue is empty. If this is not the case, then else part will get executed. and that printed element deleted from Q is %D, which will come from element which is pointing to front, because deletion is possible from the front end. After this, front will be incremented by 1. Using of else and then delete function. Last one is display function. In this, let's display elements available in queue. Again, we have to check whether elements are actually available in queue or not. So, if front is equal to -1, in that case, printer queue is empty. Else, printer queue is displayed in new line. This will come from for I is equal to F, that is we are starting from the front end. I is less than equal to R, and then we have to increment value of I. Enter element will be displayed on new line. Saving of else and saving of display. Let's save this program. Let's execute it. Following instruction. Now operations are displayed. Let's take choice 1, insert element. Suppose I am inserting 2, and again it's coming enter choice. Suppose again I am going to insert a particular element, choice as 1, element as 3. Again it will ask for whether we have to continue enter choice. For that I am putting choice as 3. I put choice as 4, then program will be executed. Let's see the output of this program again. Enter choice 1, insert element. Again enter choice, I am inserting second element. Let's display result. So 1 and 2 I have inserted, that is getting displayed. Let's take choice as 2 now. First element will get deleted. That means first element, that is 1, is getting deleted.